So here in this case, I want to prefer another methodology here, and first I will introduce that methodology to you. And it is a very effective technique, especially for superposition principle. But the method which we will discuss today has some limitations. The method which I am trying to discuss today, it is applicable to the circuits which consists of only the voltage sources. If there is a current source, we cannot use that particular technique instead. Here, before going to this problem, I will discuss one method, and that method is known as a direct inspection method. This is the shortcut method. Generally, we will use such kind of the methods in case of the online examination or maybe in the gate examination. I will discuss that method, which is direct inspection method. No need to write anything, just focus on what I am trying to explain. Here in this case, suppose this is the given figure, and for this particular figure, I want to use the direct inspection method. How it will be the direct inspection method? Suppose this value is 50 volt, maybe this may be the 5 volt, this may be the 2 ohm, this may be the 3 ohm, it may be the 4 ohm, this is 5 ohm, and it may be the 6 ohm, something like this. How is this method? Generally, what we are doing, we are applying the KVL to this, KVL to this, KVL to this, generally in case of the mesh analysis, and we are preparing the three equations. This is right. Just I will show you how are the three equations. Generally, this is the plus terminal, this is minus, this is plus, and this is minus. This is positive, negative, this is positive, negative, depending on the direction of current. This is plus, minus, this is plus and minus. Similarly, this is plus, minus, and this positive term of the battery, negative term of the battery. Is it right? If we are applying the KVL to the loop 1, how is the procedure? Look at carefully. We have already discussed it. If we are applying the KVL to this, negative to positive, which is a plus 50, then minus, it is 2 into I1. If I have taken this as I1, this as I2, and this current as I3, it is 50 minus 2I1 minus 3 into, it is I1 minus I2, which is equal to 0. If we are simplifying this equation, 50 minus 2I1 minus 3I1 minus of minus plus, it is 3I2, which is equal to 0. And its final equation will be minus 5I1 plus 3I2, which is equal to minus 50. This is equation 1. Is it right? This much procedure is required. But if you are aware of the shortcut, in that particular case, no need to use this clumsy process that I am trying to show. Is it right? If we are applying the KVL to the loop 2, if we are traveling from this point into the loop 2 in the clockwise direction, positive to negative, that is minus 3 into its current will be, that is I2 minus I1, then it is minus 4 into I2, then minus 5 into I2 minus I3, which is equal to 0. If we are simplifying this method, or if we are simplifying this equation, it will be minus 3I2 minus of minus plus 3 into I1, minus it is 4I2, it is minus 5 into I2, minus of minus 5 into I3, which is equal to 0. Is it right? If we are simplifying this equation, how will be the equation? It is 3I1 minus 3 plus 4, 7, and this 5. How much? 12, I guess. 12I2, which is minus, plus 5I3, which is equal to 0. This is the equation number 2. And similarly, if we are applying the KVL to the loop 3, how will be the equation? If we are traveling from this point into the loop in the clockwise direction, it is a minus 5 into its current, and its current is I3 minus I2 is the current for this particular mesh. Now here in this case, if we are applying the KVL to the loop 3, we are traveling from this point positive to negative, which is minus 5 into its current is I3 minus I2, then minus positive to negative, which is minus, it is 6 into I3, then positive to negative, it is a minus 5, which is equal to 0. Is it right? If we are simplifying this equation further, it is minus 5 I3 minus of minus plus, it is 5 into I2, then it is minus 6 I3 minus 5, which is equal to 0. It's in this particular case, if we are finding this equation, it is 5 I2, this is minus 6 plus this 6 plus this 5, 11 I3, and if we are shifting this constant to the next side, which is equal to 5, this is equation number 3. But here, if we are interested in the calculation of its equations, in that case, we have to repeat this procedure. It is very lengthy. That's right. But there is another shortcut. You can obtain this equation directly. That method I am trying to discuss. But be careful. Whenever the problem is asked based on the mesh analysis, you have to use this method only. But if you are using the mesh analysis in some other method, in that case you can use this direct inspection method. How is the direct inspection method? That I will discuss. Here, in that case, here these equations can be arranged something like this. These equations can be arranged something like this. Means here is a matrix. This matrix, it is a minus 5. Then we have here it is I2 is 3, I3 is 0 for the equation 1. For equation 2, it is 3. This is minus 12. This is plus 5. Is it right? And for this equation 3, I1 is 0, I2 is a 5, and I3 is minus 11. Is it right? And here in this case, this is I1, I2, and I3. These are the multipliers, which is equal to, these are the constants. What is the first constant? It is minus 50. This first constant is minus 50. What is the second constant? 0. What is the third constant? 5. Which generally we will arrange in this particular form. These equations can be arranged in this particular form. Is it right? But in place of arranging this equation, preparing this equation and preparation of this matrix, we can prepare this matrix directly. That's why this method is known as the direct inspection method. The same matrix can be written as something like this. This is R11. Here it is R12, R13. This is R21. This is R22. Here it is R23. It is R31. It is R32. Finally, it is R33, and which is equal to, here the currents are I1, I2, and it is I3, which is equal to the constants, and the constants are C1, C2, and C3. Is right? Constants are C1, C2, C3. We can prepare this matrix by observing the figure itself. No need to do this clumsy process. Is it right? How is the case? I will discuss. How is the case? I will discuss. If anyone has any doubt, please raise your hand. Is it right? If you have any doubt, please raise your hand. Now here in this case, in this particular case, now look at carefully, what is this R11? R11 is a resistance of the first loop only. This is first loop. How much is the resistance of the first loop? Can anyone answer? Chaya, Rishikesh, Saurabh. Yes. Are you able to answer? Yes, yes. 3 ohm and 2 ohm. Yes, it is 5 ohm. Is it right? Yes, sir. Yeah. Now here, you can unmute yourself whenever I will ask the question. Now here, in this case, how we will prepare this matrix? Look at carefully. R11 is the resistance of the first loop. Resistance of the first loop is 3 plus 2 is a 5. That is 5. Fine. Is it right? Then we will prepare R22. R22 is the resistance of the second loop. This is our second loop. How much is the resistance of the second loop? 5 plus 3? 8. 8 plus 4. That is 12. This 12 is the R22. Is it right? If I am doing wrong, please remind me. Yes. Then we will find out the R33. How is the R33? R33 is the resistance of the third loop. R33 is the resistance of the third loop, and we will find out academia. Now here in this case, we will find out its value, which is 11. It's right. यहाँ तक किसको doubt है? Anyone has difficulty? Saurabh, Chaya, Sheikh Naushad. Yes, any doubt? No, I guess. Is it right? Now, only diagonal elements are the positive and remaining all elements are the negative in this method. I will show both matrix, both equations, and I will justify how these equations are correct. Is it right? Now, next we will find out these two values simultaneously. We will find out these two values simultaneously. Which are these two values? The resistance which is common for the first and second loop, or second and first loop. This was first loop, this was second loop. The resistance which is common for this both loop is 3 ohm. Its value will become -3, and this is also -3. Is it right? This resistance R12, R21. Is it right? Similarly, next we will find out these two values, R13 or R31. The resistance which is common for the first loop and third loop. There is no resistance common for the first loop and third loop, because this is first loop and this is third loop. There is no common element. That's why it is 0. This is also 0. About these two values. Now we will find out the resistance which is common for the second and third loop. Is it right? Second and third loop, or third and second loop. This is second loop, this is third loop. The resistance which is common for these two loops is 5, but its value will be the -5, and this is -5. Is it right? -5 and -5. Only the diagonal elements are positive. Only these elements are positive in this method. Remaining all elements are the negative. Then the unknowns are, first loop is the I1, second loop current is the I2, and third loop current is the I3. That is the two, which is equal to the constants. Now, how to find out the constant? While finding the constant, move along with the assumed direction of the current. We have taken this direction clockwise. We will move clockwise, and just we will find out the sum of the voltages. If we are traveling in this case, negative to positive, that is a +50, and then there is no other source, that's why its value is a +50. How much is the value of this? Voltage is available in this loop. There is no voltage in this loop, that's why 0. In this particular case, if we are moving clockwise with the direction of the current, positive to negative, that is a -5, because we have only one source in that case. By looking at the figure itself, we can prepare this matrix directly, and that method is known as the direct inspection method. And from this matrix, we are in a position to find out its current, maybe the I1, maybe the I2, or maybe the I3 within fraction of seconds. We can find out the values. Now look at what is the difference between this matrix and this matrix. ये माइनस है, ये प्लस है, ये प्लस है, ये माइनस है, ये 0, ये 0, ये प्लस है, ये माइनस है, ये माइनस है, ये प्लस है, ये प्लस है, ये माइनस है, ये 0, ये 0, ये प्लस है, ये माइनस है, ये माइनस है, ये प्लस है. This is I1, I2, I3, ये I1, I2, I3. This is -50, this is +50, this is 0, this is 0, this is 5, and this is -5. Throughout, sign change is there. Means what? I will show one example here. अगर इस मैट्रिक्स का मल्टीप्लिकेशन करते हैं, दिस रो is multiplied with this column which is equal to the first value. Is it right? This, how is this equation? That is 5i1 minus 3i2 which is equal to 0i3 which is equal to 50 is the equation. This equation is very same as this equation. Look at carefully. जस्ट इस इक्वेशन को हमने क्या किया, माइनस साइन से अगर मल्टीप्लाई करते हैं इस इक्वेशन को, तो इक्वेशन क्या होगा, प्लस 5i1 minus 3i2 which is plus 50. This indirectly what I meant to say, this equation and this equation, both equations are same. At the same time, if we are checking the second equation, this row into this column is equal to this value, means it is minus 3 into i1 plus 12i2 minus 5i3 which is equal to 0. This equation is same as this equation number 2. Look at carefully. If we are multiplying by the minus sign here, this equation will become minus 3i1 this is minus 3i1, this is plus 12i2 minus 5i3 which is equal to 0. At the same time, if I am taking the third equation from here, which is 0i1 minus 5i2 plus 11i3 which is equal to minus 5. And check it out, this equation. This is minus 5i3 plus 11i3 minus 5. This is the third equation. Which indirectly what I mean to say, this set of the equation is very same as these equations, and these equations can be prepared by this method, and I am planning to use this method in superposition. Is it right? Now I will communicate one by one. हर एक के साथ मैं डिस्कस करूंगा, and I will use this method in the next problem which I have planned for the today's session. Is it right? I will come back to you. Chaya, any difficulty in understanding this direct inspection method? ये जो हमने मैट्रिक्स बनाई, इस मेथड को समझने में कुछ डिफिकल्टी है क्या?
No sir.
No, you understood that.
Yes sir.
Okay, fine. Rishikesh.
Yes sir.
Yes, sir. Whatever we have discussed this method, direct inspection method, have you understood that method?
Yes sir. Yes sir.
Okay, fine. Saurabh.
Sir, understand.
Okay, fine. Naushad, have you understood this method? Naushad, yes or no? Hello? Hello? Okay, fine. I will come back to you later. Is it right? Now here, with this basic principles in mind, I will try to explain this method with the same philosophy. This here, why I am using that method, I will discuss that first. Now here, copy this problem. In this case, we are interested in the calculation of current in 50 ohm resistance using superposition theorem for this given network. For this given network, we are trying to use the superposition theorem. Is it right? How is the superposition theorem? We will consider the first source at a time. We will remove the sources by its internal resistances. Is it right? Then we will draw the figure for case 1, and in that case, in that method, in place of using the reduction technique, reduction series and parallel combination or nodal analysis method, here I will use the mesh analysis method, and in the mesh analysis method, I want to use this direct inspection method. Is it right? Try to understand it. Case 1. Now look at what I am doing in the case 1. In first case, I will consider this 45 volt source. We will consider 45 volt source. By that time, remaining all sources are replaced by respective internal resistances. Why I am using this method? क्योंकि इसके पास 1 2 3 सोर्सेस है, मींस हमें 3 बार करंट निकालना पड़ेगा, फिर इसमें ये स्टार आएगा, स्टार टू डेल्टा, डेल्टा टू स्टार कन्वर्शन हमें करना पड़ेगा. मींस इफ वी आर यूजिंग द रिडक्शन मेथड फॉर फर्स्ट केस इट इज कॉम्प्लिकेटेड, फॉर सेकंड केस अगेन इट इज कॉम्प्लिकेटेड, फॉर थर्ड केस अगेन इट इज कॉम्प्लिकेटेड. That's why this problem itself becomes complicated. In place of using the reduction technique, I will use here the direct inspection method. So here in the direct inspection method, how will be the figure? This will be something like this. This 45 volt source remains as it is. Then remaining all sources we are replacing by its internal resistance. It will be replaced by its internal resistance. Then it is 15. Then it is 5. And finally we are removing this internal resistance. This source by its internal resistance. It is 5 ohm, this is 5 ohm, it is 15 ohm, it is 20 ohm, and it is 10 ohm, and it is 45. Now in this method, in what value we are interested in the case 1? Look at the problem. Calculate current in 15 ohm. Means case 1 में हमें 15 में करंट निकालना है, केस 2 में 15 में निकालना है, केस 3 में 15 में निकालना है. What I will do here, I will assume the 3 independent currents. Here this current is I1 for case 1, this current is I2 for case 1, and this current is I3 for case 1. Case 1 के लिए मैं ये करंट I1, I2, I3 assume करूंगा. Is it right? And we will prepare its matrix directly. Look at this. We will prepare its matrix directly. Is it right? This matrix I am trying to prepare. Now look at how this method is simple now. We will prepare this matrix directly. This current, first current is I1, second current is I2, third current is I3. These are the constants we will find out. But how is this matrix? I will draw somewhere here. This matrix is R11, it is R12, R13, R21, this is R22, R23, this is R31, R32, and finally it is R33. It is something like this. This matrix is something like this. First we will find out this R11. How much is the R11 for this case? ये हमारा loop 1 है. How much is the R11? Can anyone able to answer? Yes or no? Its resistance is of this first loop is how much? Anyone? Chaya? Saurabh? Yes, Saurabh?
30 ohm.
30 ohm, absolutely correct. This is 30. How much is the R22? This is second loop. This is 15 plus 5 is a 20, 20, and this 20 will be 20. How much is the resistance of the third loop? This third loop. This is 5 plus 5 is a 10, and this 10 will be 20. This is 20. Only diagonal elements are the negative. Remaining all elements will be positive. Is it right? Remaining all elements will be positive. So how is the case? Yes. Saurabh, anything?
R22 40 होगा ना?
R22?
40.
Just wait. Yeah, it is 40. Correct. Because this is 20, this is 15 plus 5 will be 20, and 20 and 20 it will be 40. Absolutely correct. Now here we are interested in R12 and R21, both simultaneously. This is one loop, this is second loop. R12 or R21, resistance which is common for these two loops. It is 20. This value will become minus 20, and this is minus 20. Is it right? Similarly, we are interested in R31 and R13, both simultaneously. resistance which is common for the first and third loop. This is first loop, this is third loop. This is first and this is the third. How much is the common resistance? This 10. Means it is minus 10 and this is again minus 10. Finally, we will find out this value. The resistance which is common for the second and third loop or third and second loop. Second and third, third and second. The resistance common is a 5. This is minus 5 and this is minus 5. That's it. How much is the constant? For loop 1, if we are traveling in the clockwise direction, constant is minus 45. For loop 2, it is 0. For loop 3, it is 0. In this case, the constant is lecture version. In this case, it is minus 45. This is 0 and this is 0. Is it right? Because if we are traveling clockwise, it is minus 45. Now here, in this case, in what value we are interested? In this case, in what value we are interested? What is the problem? Problem is calculate the current in 15 ohm. Means here we are interested in current in 15 ohm, or is 15 ohm में current को हमने case 1 में नाम क्या दिया है? But the name we have given I2. Means we are interested in I2 only. Now enter these values in the calculator and find out the value of the current I2, which is for case 1. I will use the calculator. Here in this case, if I am using the mode, then I will go to the equation. Unknowns are 3. How much is the first value? 30. Then second is minus 20. Then third is minus 10. Then this value constant minus 45. It is minus 45. Then A2, it is minus 20. Then this value, it is a 40. The next, it is minus 5. The next, this value is 0. The next A3 is minus 10. Then it is minus 5. The next value is 20. The next value is 0. And in this case, X, with I1, it is minus 3.77 amperes. Next is I2. It is minus 2.189, means 19 amperes. And I3, it is minus 2.43 amperes. Is it right? These are the values. Is it right? Yes or no? Check it out, the values. Saurabh?
Yes, sir. Correct.
Correct. These are the values. Means we are interested in the current I1, I2 and I3. For case 1, these are the values. Is it right? This is I1, I2 and I3. Similarly, if we will use the case 2, out of these values, we are interested in this value. कोई गड़बड़ तो नहीं हुआ एंटर करते समय? It is minus 45 सही है? Sorry, there is a mistake. This value constant, क्योंकि ये माइनस नहीं आना चाहिए. Because if this is a battery, ये भी इस बैटरी के हिसाब से चला, ये भी. But here in this case, I have taken this minus 45. It will not be the minus 45. If we are trying to clockwise direction, negative to positive, it should be the plus 45. This value is the plus 45. We have to redo the calculations. सभी calculations फिर से एक बार करना पड़ेगा. A1 is a 30, B1 is minus 20, C1 is minus 10, and this value is a plus 45. Is it right? A2 is 20, this is 40, this is 5, that is again, okay, fine. Now, this C3 is 20, this is 0, and this value is 3.77. It is right, absolutely correct. This is plus 30. The second one is 2.18, it is a plus 2.18, and this is 2.43 amperes. Now it is correct. Is it right? Because by mistake, I have taken this value as a minus 45, because as per the rule, if we are traveling in the clockwise direction, negative to positive travel कर रहे हैं, इसका value आना चाहिए 45 plus 40. That is the case 2. Is it right? Now, how is the figure for case 2? In case 2, we will consider this 120 volt source. सिर्फ इतना calculation, इतना steps लगेगा आपको. Is it right? Now here, in the case 2, how will be the figure? I will replace this source by its central resistance. This source by its internal resistance, sorry, this source I am considering, that is 120 volt source. This is 120 volt. This is plus and minus. Here is 20 volt, sorry, 20 ohm. This is 10 ohms. This is 5 ohms. This is 15 ohm. Is it right? Here it is. It will be something like this. हमारा फिगर कुछ ऐसे होगा. ये 15 ohm है. ये 20 ohm है. This is 5 ohm. This is 10 ohm. This is 5 ohm. And this is 20 ohm. Now I will prepare the matrix again. I will prepare the matrix again. For this case, look at the matrix. It will be something like this again. But in this case, I have given the names as I1, I2, I3. I will give some different names here. This current I will give I1 dash. This current I will give it as I2 dash. And this current is I3 dash. Same. I1, I2, I3 for case 1. The same current I1 dash, same current I2 dash, same current I3 dash for case 2. And in case 2, what we have done, we are considering 120 volt source. 120 volt source. Is it right? So here, what the changes we are doing in the figure? इस figure के comparison में इस figure में क्या changes है? Figure is almost same. Only this source is considered here, which is this, and this source is replaced by this. What about the resistances? These are the same. If the resistances are same, this matrix will be the same. Yes, Saurabh, I will come back to you. Yeah. Yes.
20 volt भी short होगा ना?
Sorry. Just here, this 20 volt should be replaced by its internal resistance. Absolutely correct. Because at a time we have to consider only one source. The source we have considered, right? Now here, this matrix will be as it is because any resistance we are not changing. We are changing the sources, means only this constant column will change. Is it right? Only the constant column will change. Right? Now here I will copy the same matrix. It is 30. This is minus 20. This is minus 10. This is minus 20. This is 40. This is minus 5. This is minus 10. This is minus 5. This is 20. This current is I1 dash. This current is I2 dash. This current is I3 dash. And the constants. Now how is the first constant? 0. How is the second constant? We are traveling with the direction of current, positive to negative, which is minus. Positive to negative, which is minus. How much is the value of this source? 120 ohm. Then for third loop, there is no source, means 0. We try to understand only this is needed to be changed. Isko copy karna hai. Is it right? So with this method, we are interested in I2 double dash only. We are not interested in any other value because we are interested in the calculation of current in 15 ohm. 15 ohm में current कितना है? इस 15 ohm में जो current है, that current is the I2 double dash. If I am using the calculator again, the values already we have entered into the calculator. A1 is the same, B1 is same, C1 is same. B1 is 0. In place of 45, I will make that 0. Then A2 is minus 20. It is 40. This is minus 5. I will change the D2, this value. It is minus 120. Sorry. Minus 120. Then A3 minus 10. Then B3 minus 5. Then C3 20. Then D3 is again 0. I will put is equal to sign. This is first value, which is I1. I am not interested in the I1. Still, I will write somewhere here. This I1 is minus 5.83 amperes. Is it right? I2 is minus 6.4. This is minus 6.48 amperes. And this is the I3. which is, I am not interested, but still I will write here, which is minus 4.54 amperes. Means in the case 2 also we have calculated the similar current. Is it right? Now I will use the case 3. If we have taken this problem by the reduction technique, अगर इस problem को हम reduction technique से solve करने का try करते तो it is lot complicated. You can try the same problem by using the reduction. Reduction in the sense series and parallel combination, that kind of the approach. Is it right? Now here we will start with the case 3. We will start with the case 3. Now here in the case 3, I will show something here. Case 3. We will consider the case 3. Is it right? This is case 3. How is the case 3? In case 3, just I will show here somewhere. This is the figure. Is it right? In case 3, we are considering this 20 volt source. 20 volt source. By that time, all sources are replaced by respective internal resistances. Respective internal resistances. Is it right? If I am trying to draw the same figure, how is this figure for case 3? Only I will consider this 20 volt source. I will remove everything. In that case, figure will be something like this. This 45 will be replaced by its internal resistance. Here will be the 20. This 120 will be replaced by its internal. This is 15. Here it will be the 10. This will be the 5, and finally I will consider only the last source, which is 20 volt source. That is the 20 volt source. Is it right? This is 5 ohm. Here this value is 20 volt. It is 5 ohm. This is 5. Here it is 15. It is 20. Then this is again 10. Is it right? This will be the figure for case 3. This will be the figure for case 3. Is it right? This is 20. This is 5. This is 5. Now here we will assume the 3 currents again. This is first current, second current, and this is third current. I will give this name as I1 double dash, I2 double dash, and I3 double dash. We are interested in this current, 15 ohm, in the case 3. How will be the matrix for case 3? I will draw its matrix here. Its matrix will be something like this, which is equal to the constants. Currents are I1 double dash, I2 double dash, and I3 double dash. Is it right? And whatever the matrix we have prepared here, which is the same. Is it right? That's why I will copy this matrix. I will copy this matrix. इसको मैं prepare नहीं करूँगा. I will copy this matrix. If I am copying this matrix, this is 30, minus 20, minus 10. This is minus 20. This is 40. This is minus 5, minus 10. Minus 5, this is 10. This is right. That's it. That's it. Now, how are the constants? If I will travel with the direction of the current for first loop, it is 0. For second loop, it is 0. For third loop, if I am traveling with the direction of the current, I am traveling from negative to positive, which is a plus. Its voltage is 20. Now we have this value. Then in this case, in what value we are interested? We are interested in only I2 double dash. This is our target. If I will use a calculator again, Already values are available in my calculator. A1 30 है, B1 minus 20 है, C1 minus 10 है, D1 0 है, fine. A2 minus 20 है, B2 40 है, then C2 is minus 5. Then D2 is not the 120, it is 0. I will make it as 0. A3 is minus 10, this is minus 5, this is 20, and last value will be again, D3 will be 20. Is it right? And which is equal to? Here I1 is, I am getting the I1 double dash. I will write somewhere here. I am not interested. I1 double dash. This value is 1.08 amperes. This I2 double dash, it is 0.756 amperes. And the third value is 1.7. This is I3 double dash. This value is 1.73 amperes. Something like this. This is right. Now finally, if I'm coming back, then as per the superposition theorem, this current, final current, I will call it as load current, is equal to, our current in this 15 ohm is equal to the algebraic summation, which is nothing but I1 plus I1 dash plus I2 plus I2 dash plus I2 double dash, because we are interested in the 15 ohm. 15 ohm में current clockwise है first case के लिए, इसका नाम है I2. Clockwise the second case के लिए, इसका नाम है I2 dash. And the same current in the same resistance is I2 double dash in the third case. That's why it is I2 plus I2 dash plus I2 double dash. How much is the value of I2? As per our calculation, this is value is 2.19 amperes. This is equal to 2.19 amperes plus. How much is the value of I2 double dash? It is minus 6.14. This is minus 6.14. Then plus. How much is the value I2 double dash, which is 0.756. And how much is the final answer? If I am trying to calculate this final answer, which is 2.19 minus 6.14, then plus 0.756, which is equal to minus 3.19. It is minus, its value of this current is minus, it is 3.194 amperes. 3.194 amperes is the current in this 15 ohm.